Okay, so now we're going to talk about gear pumps. Gear pumps, number one, you're going to have to remember they are low cost and durable, which is why we've got them in the lab and why they're so widely used in many, many hydraulic applications. If you run a tractor, chances are that tractor has a gear pump in it. Why? Because it can be relatively durable in case there's a little dirt that gets in your hydraulic line, a little air, a little bit of a little chunk of something. That will not destroy a gear pump as easily as it will a variety of other pumps. The most common gear pump is what's called an external gear pump. And the book has got a great little picture of, once again, a side view of an external gear pump. Now, I have given you guys a link in the D2L site to see a little animation of this. The liquid squishes into, I'm not sure exactly the orientation of this, but let me flip you to the PowerPoint I've pulled together. The liquid squishes into the inlet and the gears spin to the outside, right? It's cheaply built because the one gear needs to be driven and it drives the second gear. So you don't have to worry about any fancy transmission. You just put a motor, attach it to your main driver, and this gear will run, and it drives its matching gear. The liquid squishes around the outside because around the outside we just have a curved surface, a round surface that grabs up little chunks of the liquid, in this case little pockets of the hydraulic fluid, and pushes it around the outside. So here is the liquid being pushed around the outside, and it's pushed around the other outside too. So it's got two cavities that it's being pushed around and then pressed into the outlet, and it creates my high pressure zone here at the outlet. As the gears spin inward, they mesh together. Therefore, your pocket of liquid is gone. The gears squish together, only a tiny amount of liquid, if the gears are nicely well meshed with each other, make it back toward the inlet side. This creates my pressure. It creates my liquid flow. And so obviously the faster the gears turn and or the bigger the gears, it creates more pressure and more horsepower and more volume of flow in these gear pumps. So the gear pumps are probably the most common item. So let me stop my share. Let's continue on. All right, so in the book, it doesn't spend a lot of time talking about the gear pumps, but it dives into a few different styles. The most common is the external, and the reason why it's called external is because the liquid is pressed around the external of the cavity, the outside of the cavity, around those gears. In addition to that, the book talks about a few different other styles, which are probably less common and definitely more expensive. For instance, they have something called an internal gear pump, right? And there's a few different styles. The book shows you a common one, which means that basically you've got a gear that runs around the outside that is basically nothing more than internal lobes attached to an outer cylinder, and that spins around the outside, and then you got a center rotor in the middle. And by offsetting this in the cavity, it allows us to pick up liquid on one side and push it, and then it doesn't allow liquid to return back to the inlet on the other side. Interesting, once again, you've got one gear meshed with another gear, an internal gear and an outside gear. And this is a little bit less common, but it has certain advantages in that there is a higher meshing of the teeth. It's a very precise fit, and that allows for a higher pressure of the hydraulic fluid, and a little bit more efficiency. It allows for a little bit more efficiency, but it's a little bit more delicate. It doesn't allow for as much dirt or as much longevity before it starts having problems. We also have a gear rotor type gear pump, and here's an example of that. It's a different shape of teeth. In this case, it's got a very specific type of star shape that meshes with an internal and external, and it can be very, very efficient as well. So I'm not going to go into either one of those. But I will mention this one thing. These pumps, these gear rotors, are very smooth in operation. In other words, you don't have this the grinding sound of teeth on teeth that you would with an ordinary gear pump, but it is very sensitive to dirty fluid. As soon as you've got a chunk of dirt in this, you lose your lovely smoothness and you got a great big crunch when it stops. So that's enough on gear pumps. Let's hold on one second. Let's see where we're at with timing. I think we're good. We can continue on. So the last style of pump is a piston pump. A piston pump is exactly what you would expect it is based on the sound of it. The book mostly talks about these high pressure piston pumps with multiple pistons inside of them. And these guys are used a lot in hydraulics for very high pressure applications. They are excellent, excellent devices. They tend to be a lot more expensive. These are probably, I would guess, the most costly of all of the hydraulic pumps on average. And I can't say that for sure because some of the other gear pumps run a lot of money as well. But the piston pumps allow for a much broader range of thickness of the oil, what we call viscosity of the oil. It allows for a broader range of functionality and can allow for extremely high pressure. So these are really sturdy, general purpose, powerful pumps. And they show a cross section here, and let me just give you a quick visualization of why a piston pump works. Because a piston pump works when you squish down that piston. In other words, your motor spins around this plate, and the plate, because it's eccentric to that piston, pushes down on that piston and squishes out some fluid to the outlet. But then some valves close when it sucks back up on the pulls on the inlet when the valve is closed. In this case, the valve is automatic because the position of the piston when it's pressed over the outlet is squishing down, and when the position is on the inlet, it's pulling up. And so let me do a little animation there. Hold on one second. I'm going to share my screen here. All right, let's, come on, let's share my screen. Okay, and here's my little screen describing how a piston pump works. Now this is not a rotary piston pump that the book is describing. This is a piston pump that is just describing a basic valve piston. And you're going to see these style piston pumps in very high viscosity applications, as well as the pneumatic. When we talk about air pneumatic compressors, you're going to see this kind of valve arrangement where your intake opens when you're pulling up your pump and your discharge opens when you're pushing down your pump. And this particular style of pump is very, very typical for very old school style liquid pumping mechanisms. For instance, this is what you would typically find in a old-fashioned well pump. It sucks in liquid from the intake from the bottom pipe when you're lifting up on the well pump, or pressing down on the handle lifts up the actual piston, which is how it works. And then when you lift up on the handle, it squishes that liquid that's in the piston out a valve and dumps the water into your bucket. So that's a very typical piston pump. Now the book itself goes through these rotary piston pumps that do it all automatically. And obviously there are a whole bunch of potential problems with this as well. So I'm going to stop the recording.